of Lecture 3, and here we're going to be looking at using the programming language Prolog. And I'm going to invoke Prolog with the command swipl, and up comes Prolog. Now, I'm going to want to load a file, so let's take a look at the file I'm going to load, which I've called ex1.pl. And it has a bunch of facts about cats and dogs, and it's got some implications and another fact which we'll use later. So these are all horn clauses. Why? Because it's either a single fact, which is true, or it's an implication with only one thing that's being implied. Now, in Prolog, this means is implied by, or if. So what this means is Fluffy eats if Fluffy is hungry. And in fact, you can sort of think of the facts as being implications too. They've got one implication on the left-hand side. It's just that they don't depend on if. It's sort of like true implies dog spike. Okay, so we've got these facts, these implications. Let's load them in and see what happens. Note that I type in the name of the file in brackets. I don't put the PL Prolog suffix, and there we go. So let's see what's true. Well, let's see. Is Shep a dog? Let's find out. Yes. Is Fluffy a dog? Oops. No. How about, is Bob a dog? No. Okay, well that makes sense because we only have facts that say Shep is a dog. What if I wanted to find out what all the dogs were? Is there some way to do that? Well, here's what we'll do. We'll say dog X, and notice that if a term begins with a capital letter, that makes it a variable, okay? And this says, is there any dog? And sure enough, yes, there's a dog named Spike. Now, if I just hit return, that says, yeah, it's true, and there is at least one dog. What about all the dogs? So let's say dog X again, but instead of hitting return, I will hit semicolon, and it'll see if there's any other way to make dog X true. Yes, with X equals lucky. And then there's one more way to do it, which is X equals Shep. Okay, so let's now see if any dog is going to eat. So I think that Shep won't eat. Why? Because we don't have any production for Shep eating, or any dog eating for that matter. But let's see if Fluffy will eat. Eats Fluffy. True! Why is that? We can run something called trace, and that'll run in debug mode. So let's try that again, and let's see why that's true. Eats Fluffy. Now we're going to backwards chain from this. So it's going to call eats Fluffy. Eats Fluffy is true if Fluffy is hungry. It's true that Fluffy is hungry, therefore it's true that Fluffy is eating, and we're done. Now notice that this is all in propositional logic other than this little thing about this variable here. But everything I've done with the cats and dogs is so far really has been just propositional logic. And we can see that, for instance, because we have productions for Fluffy and Godzilla eating, they can both eat, but we don't accept that only Fluffy is hungry. So no dog is going to eat and Godzilla isn't going to eat. Let's try that out. So let's see. Eats X. So let's see what it eats. Oops, I still have trace on. Well, let's see. Fluffy's hungry, right? And then let's try to see if there's any other way to do it. Well, there's no other way to do it because there's no fact in the database that says Godzilla is hungry. So let's turn off trace and turn off debug, and we're back to normal. Okay, so let me load one more file, which I will show you here in a minute. So let's take a look at this one. So far we've just been doing propositional logic. Here's a little bit of predicate logic. And I've got a horn clause that's an implication, and this says X is mortal if X is a dog. So let's load that. Okay. Let's find out if Shep is mortal. Now this should be true because Shep is a dog and you're mortal if you're a dog. It is. Is anybody else mortal? Let's find out. Well, Spike is mortal because he's a dog. Lucky is mortal because he's a dog, and Shep is mortal. What about, let's check to see if Fluffy's mortal. We don't think he's mortal. Oops. No. Now, the fact is that in real life, all cats are mortal, but it says that Fluffy isn't mortal. How can that be? Well, that's because we're looking at the knowledge base, and there's no way to entail Fluffy being mortal from the facts and relationships in the knowledge base. So there was some other material in EX1 here. So it's a bunch of facts. They're all perfectly valid Prolog statements. So P of A is a fact, P of B is a fact, and so forth. And we're going to play with these a little bit, including the trace, to see Prolog's backward chaining in action. So we know, for instance, P of A. Okay? Now, let's see if P of D is true. It is true. Now, let's trace it and see the backward chaining that it used. Okay, so P of D is true if P of A. Okay. P of A is true, therefore P of D is true, and it's true. What about the fact that there was a way to show P of D that wasn't true, namely because there's no P of E? Well, it doesn't matter because we had a way of showing P of D using P of A. What about P of F? Let's try that one. This should not be true either. Okay, call P of F, and P of F is true if P of A is true and P of E is true. Okay, so P of A is in fact true, and now it's going to call P of E. But P of E fails because there's no fact P of E, and so P of F fails. Right? And that's how backward chaining works in Prolog. Now, the other thing I want to chat with you about is using Prolog to represent stuff we know about. So, for instance, here's a little fragment of Prolog code which I just want to explicate for you. So, each predicate has what's called an arity. How many? And this percent sign means it's a comment. This says that I'm defining, in my comment, I'm saying I'm defining a predicate called room, and it has arity 2. The arity is the number of arguments. So we can see that, in general, the first argument is supposed to be the coordinate for the room, and the second argument is going to be a list. And in Prolog, a list is a left square bracket, and the items in the list are separated by commas, and it's ended by a right square bracket. So this is going to define predicate room of arity 2. So here are some examples, and these are rooms we know about. So in the example of the 1 plus world we've been working with, room at coordinates 1, 1 was perfectly safe, and it had no breeze, stench, or glitter in it. So basically, here's the coordinate, and it's another predicate of arity 2, where the name of the predicate is coord, and the two arguments are the x and y axes. And then the second argument is this list of what we can perceive and what's there. So If there's none here, that means there's no stench, there's no breeze, there's no glitter, there's no wumpus, and there's no pit. In room with coordinates 1, 2, that's just above where we are, there is a stench, but there's no breeze, glitter, wumpus, and pit, and so forth. And so this gives us a way of defining declaratively what the layout and contents of the wumpus world will be. So that's a brief introduction of Prolog. We'll have a chance to play with this in class.
And I'll see everybody then.